of arc length S. So from here to here is the arc length, which we're calling S. Of course, the radius is from the center to the outside. And the central angle we learned in grade 9 was the angle that has a vertex in the center of the circle. What was the other one called, by the way, in grade 9? The one that went to the outside. An inscribed angle. Okay, so anyways, that's just an aside. For example, if a central angle in a circle has a radius 3 and opens to an arc of 6, then the central angle would be 6 divided by 3, which would give me 2. So the formula that's on your formula sheet when you get it has S equals theta R. Note, theta must be in radians. Remember, I switched 360 degrees to radians in order to cancel the 2 pi as part of the circumference formula. Also note that the textbook uses the letter A instead of S in the formula, but because the formula sheet comes from the provincial exam, we are using S because that's what they use. But in the end, it's just a variable, right? As long as you know what that stands for, it's all good. Okay, so if a wheel has a radius 0.5 meters and rolls 1.5, if you have this wheel and it rolls, what's this length actually called? Well, that would be the length that goes around the circle, right? Rolling, just flattened, right? So that would be my arc length. So it's giving you an arc length, it's giving you a radius, and it needs to know how many radians it turns. So we're using the formula theta equals S divided by R. My S is 1.5 meters. My radius is 0.5 meters. Notice that they're both in meters. If they're not, you need to have it to the same unit so that they can cancel. Why? Because radians does not have a unit, right? So what's 1.5 divided by 0.5? The trick for dividing decimals is if you move this decimal and you move this decimal, it's the same thing as 15 divided by 5, which is 3. That means 3 radians. That's theta. Very good. Okay. Find the arc length given the diameter is 10 and the central angle is 700. If I need to find my arc length, I need to know theta, which has to be in radians. So what's the first part of the question? Yeah, they give you your theta in degrees. How do I change 700 degrees to radians? Pi, times it by pi over 180 degrees. Very good. So the 0 and the degrees cancel. Does anything go into 70 and 18? Two, yeah, 35 and 9, and that's about it. So I get 35 pi over 9. Leave it as an exact value. What's the deal here? It says diameter. How do I change diameter to radius? It's going to be halved. Okay, so that means I can now figure this out. It's going to be 35 pi over 9 times 5 centimeters. What's my answer going to be in centimeters? Does everybody see that? Now I'm going to punch in my calculator and I'm going to have it correct to 3 decimal places, which means I'm going to truncate it at 4. So, because that's my conversion there. So I get approximately 61.0865 centimeters. Did everybody get that when they punched it in their calculator? If you happen to punch the radians into the calculator and got an answer and rounded or truncated, then put it into the next formula, you would lose a half mark, because the rule in this course is you cannot round until the final answer. So you can either find this, keep it as your answer key, and use it in there so it's the complete value, or you just kind of reduce this and put it in there. All right. Okay, find the measure of the central angle in degrees. It should be in degrees, not is degrees. So, if they're measuring the arc here, does everybody see that your central angle would be this right here? Yes? So theta would be S divided by R, so it's 25 centimeters divided by 5 centimeters. Everybody see my centimeters cancel? And I get 5. What is that? Radians. It's asking for it in degrees. So what would I have to do to convert this to radians? To degrees, sorry. I need to times it by 180 over pi. Okay, so we're going to figure out what that is. And what did we get? 286.4788 degrees. Yeah? Okay, any questions? Okay, moving on. Find the length of traveled by a bicycle with radius 20 centimeters and a central angle of 120. Why don't you guys try this one? The length traveled, of course, is the arc length. That is in degrees. So what do I need to do to 120 first? Times it by pi over 180. So the 0 and degrees cancel. 6 goes into both of them 2 and 3 times. So this would be 2 pi over 3. Okay, so then I'll punch her in. 2 times 2.8879 centimeters. Everybody get that? Is that a yeah? Okay, next off, this would be a no calculator one. It says, and the does everybody see the pi will cancel? Just left with 2.46, and that would be centimeters, yes? Okay, next one.